Hello friends, welcome back to my channel Mathematics Olympiad. So today we shall be considering our exercises. The first one is if 5 raised to power a equals 7 raised to power b equals 1225, find ab over a plus b. Now the first thing we do here is to equate our 5 raised to power a rather equals 1225. Then we multiply both powers by 1 over a in order to eliminate the power a on 5. So we have 5 raised to power a multiplied by 1 over a. The dot there means multiplication equals 1225 raised to power 1 over a. That is, we have 5 raised to power a times 1 over a equals 1225 raised to power 1 over a. Then the a cancels a. We have 5 equals 1225 raised to power 1 over a. That's our equation 1. Now the second one, since we have 5 raised to power a equals 7 raised to power b equals 1225, we have two equal signs there. We can also equate 7 raised to power b equals 1225. So if we multiply both powers again by 1 over b, we have 7 raised to power b times 1 over b equals 1225 raised to power 1 over b. Then b cancels b, so we have 7 equals 1225 raised to power 1 over b. That will be our equation 2. So now if you multiply the two equations together, equation 1 and 2, then we have 5 multiplying 7 and 1225 raised to power 1 over a multiplying 1225 raised to power 1 over b. So what we have here now is 5 times 7 will give us 35, which equals 1225 raised to power 1 over a plus 1 over b. We got plus there because they have the same base, and according to the rule of indices, when you have multiplication and the base are equal, you can just add the power. So that you take one of the bases and then add the power. So that's how we arrive at 35 equals 1225 raised to power 1 over a plus 1 over b. Then if we find the SM of A and B as the power of 1225, the SM is AB. So we have 35 equals 1225. The SM is AB. A in AB. A will cancel A. We have B left. So B times 1 will give us B plus B in AB. B cancels B. Then we have A left. A times 1 is A. So we have 35 equals 1225 raised to power B plus A over B, or 35 equals 1225 raised to power A plus B over AB. So we have 35 equals, if you break down the 1225 in order to have base of 35, which will give us 35 square. 35 square equals 1225. So we have 35 equals 35 square raised to power a plus b over ab. So 35 is the same thing as 35 over 1 equals 35 square multiplied by a plus b over ab. So since they have the same base, we can cancel the base and equate the powers. Then we have 1 equals 2 open bracket a plus b over ab. So now we have 1 equals 2 open bracket a plus b over ab. Then if we divide both sides by 2, the coefficient of a plus b over ab, we have 1 over 2 equals a plus b over ab. So since they ask us to find AB over A plus B, all we just need to do is to find the inverse. So if we find the inverse, we just flip or turn it upside down. So we have 1 over 2 equals 2 over 1. Then equals AB over A plus B. That means AB over A plus B equals 2. And that's our final answer for that question. So question number 2 says x raised to power x equals 2 raised to power 2048, that is 2 raised to power 2048. So we can just break down 2 raised to 2048 by 2 divided by 2, and then we have x raised to power x equals 2 raised to power 2 multiplied by 1024. The 2 raised to power 2 will now become 2 raised to power 2, that's 4. Then we have 4 raised to power 1024. Then if we break down 1024 again, that is divided by 2, and raise the 2 to power of as the power of 4, then we have x raised to power x equals 4 raised to power 2 multiplied by 512. So the 4 raised to power 2 So we now have x raised to power s equals 4 raised to power 2 will become 16, then raised to power 256. So if we divide 256 further by 2, then we raise the 2 to power of 16. Then we have x raised to power x equals 16 raised to power 2 multiplied by 128. Now if you now 16 raised to power 2 will give us 256. So that means we have x raised to power x equals 256 raised to power 256, and that's what we're trying to achieve, to make sure that the base and the power are the same. So far the base and the powers are the same on both sides, we can equate the base or equate the power. So we have x equals 256. That's our final answer for that question. Now this particular question we have treated it before, but I'm trying to make correction on the power here. So we have x raised to power root of x equals 1 over x raised to power 2. So x raised to power root of x equals 1 square x squared. That is, we open the bracket at the right side, we'll give the square to both 1 and x. So we have x raised to power root of x equals 1 square over x squared. Then x raised to power x root of x equals 1 square is 1 over x squared. Then x raised to power root of x equals the inverse 1 over x squared means inverse of x raised to power minus 2 according to the rule of indices. So we have x raised to power root of x equal x raised to power minus 2. So we have root of x equal minus 2 because the base are now equal. So we have root of x equals minus 2. And root of x is the same thing as x raised to power half, which is equal to minus 2. So if we multiply both power by 2, we have x raised to power 1 over 2 times 2 equals minus 2 raised to power 2. Then we have x equals 4. That is minus 2 times minus 2 is 4. Minus times minus is plus 2 times 2 is 4. Then at the left side 2 cancels 2. That's why we have x left. So x equals 4. So our exercise is number 1 for assignment is root 7 root of 9 raised to power 3 plus 9 raised to power 3 plus 9 raised to power 3. Simplify. Exercise number 2 says simplify 2 raised to power 100 minus 2 raised to power 99. Then exercise 3 and 4. Exercise 3 says 5 raised to power x plus 5 raised to power x plus 5 raised to power x plus 5 raised to power equals 1000. Find x. The exercise 4 says prove that 0 over 0 equals 2. So the last exercise here is exercise 5, which is simplify 3 into bracket 9 raised to power 99. Now, thank you for listening. We shall treat all the questions together in our next class. Don't forget to share the videos with your friends, to click subscription, notification, and like button.